Your 400-word document shows up as 612 tokens in ChatGPT. Same content, different number. What's going on? Today, we're solving the mystery of why AI counts weird and why it matters for everything you do with AI. This mismatch drives people crazy. You carefully craft your prompt, stay under what you think is the limit, and suddenly you're getting context exceeded errors. Or you're estimating API costs based on word count, and your bill comes in way higher than expected. The reason comes down to something fundamental about how AI processes language. AI doesn't see words the way we do. It sees something called tokens. And understanding tokens is going to explain a lot of AI's weird behaviors. Most people guess that one word equals one token. Makes sense, right? Or maybe one character equals one token. Also logical. Perhaps sentences are broken into some number of tokens based on length. All reasonable guesses, all wrong. The truth is more interesting because it reveals how AI had to solve a fundamental problem. How do you create a system flexible enough to handle any text in any language, but efficient enough to actually run? Tokenization is the answer to that question. Tokens are chunks of text, whole words, parts of words, or punctuation. Common words stay whole. Rare or complex words get broken into smaller, familiar pieces. Understand becomes under plus stand. ChatGPT becomes chat plus G plus PT. Tokenization becomes token plus ization. AI breaks language into efficient pieces based on learned patterns from training data. Tokenization happens before AI can understand content. Input, I don't understand ChatGPT. The algorithm analyzes frequency patterns and optimal chunking. Output, I don't understand chat GPT. Result, 7 tokens from 4 words. Notice spaces and punctuation count as tokens. Every element is precisely chunked. Even invisible characters matter. The, and, said, because, all single tokens. Why? These words appear constantly in training data. AI memorizes around 10,000 of the most common English words as a single token. It's vocabulary shortcut that makes processing efficient. But here's where it gets interesting. When AI hits a rare or complex word, it has to break it down. Archaeology becomes 3 tokens. Entrepreneur becomes 2. That made up word supercalifragilistic? 6 tokens, each one a piece that AI recognizes from other contexts. This is why technical writing, academic papers, specialized content, all of it uses more tokens than everyday language, even when the word count is identical. Your 400-word medical research abstract might be 600 tokens. Your 400-word casual email might be 520 tokens. Same number of words, different token efficiency, and that difference has real consequences. In English, hello, how are you is 6 tokens. In Arabic, the same meaning, but it's 12 tokens. In Chinese, the same meaning, but it's 10 tokens. Because most AI training data is English-centric, non-English languages require 2 to 4 more tokens for identical content. This impacts context limits and API costs, creating real inequity in AI accessibility. Every single character matters. Contraction split. It's becomes 2 tokens, don't becomes 2 tokens, but here's the weird part. Spaces before words become part of the tokens. Hello with a space is a different token than hello without one. This is why when you're optimizing prompts for efficiency, removing unnecessary spaces and punctuation actually saves tokens. Not a lot, but it adds up. Every character is being counted and processed. Nothing is invisible to the tokenizer. Tokenization solves a fundamental problem. How do you create a system that's both flexible and efficient? Too few tokens, every word, millions of unique tokens, massive memory, slow processing. Too many tokens, every letter, Handles anything, but it's incredibly inefficient due to huge sequences. The sweet spot? Well, modern AI uses around 50,000 tokens, balancing flexibility and efficiency. This enables AI to process your requests in seconds. Remember our discussion about context windows in video 2? Here's the detail we didn't cover then. When AI says it has an 8,000 or 100,000 context window, it's counting tokens, not words. 8,000 tokens sounds like a lot, but because English averages about 1.3 tokens per word, your actual capacity is around 6,000 words. Not 8,000 words, 6,000 words. And that gap gets worse with technical content, code, or non-English languages. Your 100,000 token context might only hold 50,000 words if you're working with Chinese text or programming code. This is why you hit context limits when you thought you still had room. Understanding this distinction helps you plan better. Don't think in words, think in tokens. And if you're using AI through an API, you're paying per token, not per word, not per character, per token. This makes understanding tokenization directly tied to your budget. Let's say pricing is $2 per million tokens. Your 10,000 word document in simple English might be 13,000 tokens. But the same document with technical jargon, maybe 16,000 tokens. In another language, could be 20,000 tokens or more. The same word count, radically different costs. If you're estimating API expenses based on word count alone, you're going to be off, sometimes by a lot. Always run your actual content through a tokenizer before finalizing budget projections. The difference between estimated and actual costs can be significant at scale. Prompt tokens consume response space within your fixed context window. Verbose of, I would really appreciate it if you could please help me understand, is about 15 tokens of filler. More efficient, please explain, is about 3 tokens with the same meaning. In a 4,000 token context window, a verbose prompt of around 500 tokens only leaves 3,500 tokens for the response. An efficient prompt of around 200 tokens leaves 3,800 tokens for a response. That's 8.5% more response capacity from a simple optimization. Remember video 14 on temperature? Temperature governs token selection, not words. AI predicts responses token by token. Temperature influences the probability distribution for each next token. At temperature 0, AI always picks the most probable token. At temperature 1, less probable tokens get selected more often, adding variety. Understanding tokenization reveals how temperature shapes output at the granular level. Contraction splitting, rare word construction, punctuation, rhythm. So here's some rough rules of thumb for planning. In English text, multiply the word count by 1.3. In code, multiply it by 1.5 to 2. Any technical jargon, multiply by about 1.5. If you're using non-English, you want to multiply by 2 to 4 or more, depending on the language. And these are averages. Your specific content will vary, but they give you a starting point for planning context usage and estimating costs without running everything through a tokenizer first. Let's work through a real scenario. So you've got 100,000 token context window. Sounds massive, right? You attach a 45,000 word research paper to analyze. That's about 60,000 tokens. More than half of your context is gone. You write a 400 word prompt with detailed instructions. Well, that's 500 tokens. Now you're at 60,500 tokens used. Available for AI's response, 39,500 tokens, or maybe around 30,000 words. It's still substantial, but notice how fast that context filled up. If you continue the conversation with follow-up questions, every exchange eats more tokens. Eventually you hit the limit and you need to start over. This is why understanding tokenization helps you structure work efficiently. Maybe split that document into sections. Maybe ask for a summary first to free up context for deeper analysis later. And tokenization isn't perfect. Sometimes the way text splits causes problems. Uncommon names like Timothy fragment into pieces, making it harder for AI to recognize them as single entities. Code variables like background color split at the capital, potentially confusing the AI about what's one concept. URLs break into many tokens, and AI sometimes struggles to keep them correct across those boundaries. When you hit these issues, try adding spaces, using quotes to signal single concepts, or reformatting to help AI understand token boundaries don't mean concept boundaries. Don't guess at token counts. Use tools. OpenAI has a tokenizer for GPT models. Anthropic has one for Claude. Most APIs return token usage in their responses. Before building anything, run your typical content through these tools. Verify your assumptions. Calculate actual costs. Compare languages if you're working across multiple. Use the feedback to optimize iteratively. Testing before building saves you from expensive surprises later. All right, 3 things to remember. Tokens aren't words. They're chunks based on training data frequency. Tokenization affects everything: context limits, pricing, prompt efficiency. And as you need to think in tokens, especially for technical content, non-English languages, and API usage. And this is one of those invisible concepts that affects everything you do with AI. And now that you know what's happening under the hood, you can use that knowledge strategically. All right, you just completed video 15 of Making AI Make Sense. We're building your understanding one concept at a time, from fundamentals to advanced topics. Coming up next, multimodal AI, how AI processes images, audio, and text together, and why that's different from just handling text. If you're finding value in this series, subscribe so you don't miss future videos. And if you need help applying these concepts to your business, that's what we do at Eau Claire AI. Visit eauclaireai.com. Thanks for watching, and we'll see you in the next one.